In the last video we introduced this concept of having a p of x or a g of x, and then further what to do when we have a p of 1 or a g of 5 and what that might look like on the right hand side. But what I'm going to do now is say, well, what happens if they ask you to sketch p of x that we have there? So what I'm going to do now is actually sketch this out for you so that hopefully this appears a bit more real and less just like some kind of concept that doesn't really mean anything. So I've got my axis here, this is x, this is y, like that. And I'm going to say, what does p of x look like? Well, we know that when p of 1 we get 2, and when we have p of 5 we get 10. So those are like coordinate points that we have. So we have the point 1, 2, and we have the point 5, 10. So you can see probably already this is going to look like the graph y equals 2x. And that's right, it looks exactly the same. It's the same thing. So we have this graph that's going to be a straight line. It's going to go through there. That's supposed to be a straight line there that I can get, and that's going to be p of x. But it's also exactly the same as y equals 2x. And the reason why we have this p of x here is so that if you have lots of lines here, then you don't have to write down, you don't have to label it y equals 2x. You can just write down that it's p of x, and then it becomes a little bit less confusing. Polynomials are useful for other things, but that's one of the reasons why it's useful. We can do the same for g of x. We can do the same for that. If we draw this out like this, when they say sketch it, it doesn't have to be completely accurate. I mean, try and make it better than this that I'm doing here. But it doesn't have to be completely right. You don't have to, plot out every point and make sure it's completely accurate. So we have 3x minus 5. So we know that the y-intercept is going to be down here at minus 5, and it's going to be a steeper line than this. So here we go. Let's try and that's not a good start. Let's do it in another color. Let's do it in purple. So we have purple. So as if we're plotting y equals 3x minus 5. So let's have kind of steep line there. That's supposed to be a straight line again. I know it's not very good. It's quite difficult to draw a straight line on here, but this is going to be g of x. And we have the points here. We have the point 1 minus 2, which is going to be somewhere here. That's going to be 1 minus 2 there. And we have the point 5, 10, which is maybe somewhere up here. They're not going to ask you to plot out points or anything, but it's just to give you an idea of what it might look like. And then I can go to ask you the question, what does, if I come down here a bit, let's say we have a new function, let's say we have a new polynomial h of x is equal to 5. What does that look like? Well, whatever x we have, this is not going to change. This right hand side is not going to change at all. And they may well ask you this in the exam. What is h of x going to look like? It's going to look the same as if we said y equals 5, which is a straight line where y is always 5. So let me do that in, what colour should I do that? I'll do it in this lighter blue. So let's say that here we have our point 5. Well, this is going to be a straight line where y is always 5. So this is going to be our h of x here. So hopefully now you get a kind of a visual representation of what a polynomial is and kind of what it looks like, and also what they might ask you if they say sketch it. Then you know what to do. It's just the same as plotting y equals. So hopefully that's given you a bit of a better idea, and in the next video I'll go on to some deeper polynomial theorems.